Hello, good afternoon. We will still wait for others to join. Okay, others can join when they can join. In the last session, we have studied synchronization in threads using the synchronized keyword by synchronizing the methods completely, and also by using synchronization in blocks. When you pass the object of, you can pass this as I want to synchronize the current class's methods body. Whatever part you want to synchronize, you can even keep it inside that. Is anybody having any questions in how to achieve synchronization in multi-threading in Java? Okay. What about others? Only Paliwad is answering. What about others? Okay, okay. Okay, fine. Then this you might already have done. Actually, I wanted to do this topic in the lab itself, but that is okay. We can do it in the session. I am okay with that. Achieving synchronization is one thing, and when you might have heard this thing in your OS lectures also, that multi-process synchronization, where you are synchronizing multi-process scenario, or you are synchronizing multiple processes running at the same time. Here you have multiple threads. That is why it is multi-threading synchronization. And you might have also heard the consumer and producer problem, in OS. You have heard about that, right? What is consumer? What is a producer process? What is a consumer process? Have you heard about these two processes? What is the use of them? Yes, can anybody tell me what is the use of consumer producer processes?
Ma'am, producer process will produce some data and put it in
Uh-huh.
a buffer, and the
Uh-huh.
consumer will consume the data from that buffer. That's
Yes,
called consumer.
yes, you are right. So you have two different threads over here. In the you have two different threads. One is the producer thread, and another is the consumer thread, and they are sharing a buffer pool in the sense. Okay, and it is nothing but type of queue only. Yeah. Okay, queue is the implementation architecture for buffer pool, because whenever what is happening over here is whenever the producer is producing certain item, right, before it produces, the consumer cannot consume. So at that time, while producer is producing the items, at that time the consumer is waiting, okay, for producer to produce the items. If there are no items in the buffer pool, then consumer cannot consume. That is one thing. And another thing is, if the buffer is full, then producer cannot produce any more items, then it has to go to sleep, right? And consumer will go to sleep when there are no items present in the pool. Means if producer is not producing anything, then consumer cannot consume, so it is also sleeping. They can go in the sleep state, ideal state. But in multi-threading, what we are doing here, the producer is producing one item and it is added into the queue, okay, in this fashion. And the producer is putting the items in the buffer pool, and the consumer also has to consume the items. But it has to occur in synchronization. Meaning, if producer hasn't produced the first item, then consumer cannot extract it. Consumer cannot extract or fetch that item. For the item to be fetched or consumed, it has to be produced first. So, while the producer is producing the item, the consumer is in the waiting state. And once the producer is done producing the item, once it is done producing the item, the producer will go in the waiting state and it will ask the consumer to consume that item. Are you getting? Both the threads have to work in synchronization over here. That is, once the producer is done producing the item, it is asking the consumer to consume that item. So it is waiting for consumer to consume. And in the same scenario, when the producer is producing the item at that time, the consumer is in the waiting state. It is waiting for the producer to produce that item. Once it is produced, the consumer is consuming it. That is the complete scenario. The use of functions like wait, notify, all we are going to see it today, because while both the processes are occurring in simultaneous synchronization, you need a mechanism for communication in between two different threads. Both are individual threads. We need something to communicate over here in such a way that once the producer is producing, it is waiting for consumer to consume. If the consumer is not notified, just the same way you write the English statement, no, the same way you write these functions also. The producer is waiting, means it is going in the waiting state, and it is notifying the consumer that, okay, now you can go ahead and consume the items. Once the consumer is consumed the items, it is going in the waiting state. It is notifying the producer to produce more items. In that way, in this scenario, the complete process is working using multi-threading. Are you getting the actual logic behind it? You wait and notify, two functions. Are these two functions clear? When you will be using it, how you will be using it, that I'm showing it to you. But when you will use wait and when you will use notify, what is producer thread, what is consumer thread, and we are going to, this buffer pool, no, for this, we are going to create one separate, unit we can create a separate class known as resource, and we can make the resources, added into this queue. Or maybe simple, we can create variable and we can increment it, whatever we are planning. But that can be done using this simple class only. But is wait and notify, these two keywords clear to you? What does wait, what will wait do, and what will notify do? Is these two words clear in your mind? Okay. Okay. Then we can move on to the actual programming. Yes. Okay. Good. Now we can move on to. Okay. So I'm planning to create a separate resource itself, known as. We can create a class itself known as resource. Okay. Now this class is going to be accessible by producer thread and going to be accessible by consumer thread. Okay, and as both these classes are threads, I am implementing runnable interface. Okay. Because both of them are threads. I'm implementing runnable interface over here. Now, the resource, in the sense, what we can do here is, I am thinking of, yes, we can simply create a variable. We can simply create a number. Okay, and we can. Okay, we are having, say for example, you might have heard about getter setter methods now, right? Getter setter methods we have done in the lab sessions. Get is for retrieving the value, and set is for setting the value of that variable. Okay, we are simply trying to set this value of variable, and we are simply going to retrieve the value of number. That's all this resource is doing. The resource class is having only two functions. It is simply putting or initializing this variable number with whatever number you are passing in the bracket. So I am initializing this number variable, and we are also simply, it is not currently, I am not returning integer over here. I am simply printing that the current value of this number is this one. Okay, and maybe after we initialize, we can also print here that the value that is put into this variable is number, and the value that you are getting out of it is also this whatever value you are currently accessing. I am creating two different functions over here for initializing this variable and for retrieving the value of that variable. Now the producer is going to produce different values for this variable, meaning the producer class is going to call put function. It is going to put or initialize this number variable constantly. We can directly keep an infinite loop over here. No need to worry about anything. We can make this process run till infinite. I'm not keeping any limitations over here. And you are simply putting the value of this. You are simply initializing this, and maybe we can create one variable I over here, and maybe we can just increment I. Yes, okay, so that will do the trick. So what we are doing here, we are simply creating an infinite loop, and we are creating this loop inside our famous function void run. Okay, because it is a thread now, so we need to implement the runnable interface, and we are using run method to override the overridden method run from the runnable interface. Now here we are simply doing only one thing. We are creating infinite loop, and we are putting this. We are calling the put function, and we are incrementing the value of I every time. So every time this number is getting initialized, it is getting new value infinitely. It is going to get. We are not limiting anything for here for now. Okay, it is simply infinite loop. Now to access this put, we need the object of this resource class. Okay, I'm creating the object of resource class here, and I can call directly r.put. I can call. Okay. We can initialize this R with the constructor. Let us do it later on. But this producer, are you getting the simple implementation? What I'm trying to tell here, that producer is simply producing or giving different values for this variable number. And what will consumer do? The reverse of it. Consumer, I am copying the complete contents of this class because it is going to be the same thing. The only difference will be it is simply getting the value. Okay. It is simply getting the value, means it is simply returning the value of this R. It is consuming or simply showing up the current value that it is going to consume. Is this so far clear in your mind what I am doing here? Look at the code and let me know if you have any questions so far. We have created, okay, we are creating a class resource. It is simply setting and getting the value of this variable. This is the resource that is going to be shared across both this, threads, right? So I'm creating the object of this class resource here, and in the run method, because it is going to be a thread, no, I'm simply putting the value infinitely, and I'm retrieving the value infinity. That is all my threads are doing so far. Okay, so far is it clear, right? Okay. Okay. Next thing what I am planning to do is, as it is going to be a thread here, right? I can create a thread and I can start a thread. I am creating a thread T1 here, okay? And I can start this thread, but I cannot start the thread without the body, without some functions body. I cannot start any thread. I cannot call these statements outside any function. So if initializing this R also, what I'm simply doing is I'm creating a constructor, simple producers constructor, and I'm passing this resource object over here. Whatever is the value of resource, okay, R, I'm just initializing this dot R equals to R. What I'm doing here is that whenever I'll be creating the object of in your main class, what is the name of the class? EQ. Okay, fine. In your EQ, whenever you are creating the object of producer, okay, yes, you are creating the object of producer and you are creating the object of consumer, you have to pass some resource R over here, right? So I'm simply creating the resource object here itself. Resource R equals to new resource, meaning our main class is this numbers object I am creating over here, resource object I am creating over here, and in the bracket I am passing R, and same for the consumer also. I am going to pass R, because why I am passing R over here? Because I want both the threads to work on the same resource, to work on the same object, to work and access the same memory block. If I were creating different resources object over here, no, then they would have different memory allocations. In the last session also we have seen we are passing this object for both the threads similarly, because I want to get and set from the same object R. That is the reason I'm passing here R in both the scenarios, where your R is the current object, which is going to be instantiated only once, meaning there is only one object for resource R, and this object which is having put and get access, we are passing here itself in producer and consumer, so that whatever is the current value of number, no, whoever is updating it, no, and whoever is getting it, they will get the same value. We are not allowing different memory allocations access over here. No, it is accessing the same memory allocation R. That is the reason I am passing the resource over here. In the last session also, we have seen the same thing. We have created threads by using the same OB1, thread T1 with the same OB1, because you want to access the same memory block. And I am passing here, I am initializing the classes variable by using this dot R equals to R. I am initializing this object. So now whenever your thread is starting, it is going to start this run method, which is going to put the value of I, where it is referring to R only. I am calling this object here itself, right? So this object is getting its memory allocation by whenever you are creating the object. No, at that time itself, it is getting this initialized, and henceforth, whatever is the memory allocation pointing towards this R is going to be same now for this R also, because you're initializing it when you're creating the constructor. So both the references are pointing towards the same memory block, which is R itself, and it is having the one and only one copy of this class resource. Whenever I'm starting this thread, no, it is going to call the run method. Okay. Same thing I can do it here also. No, in a consumer, I am creating the constructor of class consumer. Okay. And I can remove the public keyword for now. That is okay for me. And I can initialize this this R I'm initializing over here. And also I can create one more thread here, new thread. You can even name it as same only, doesn't matter. Okay, you can even name it as T1 itself, because both are, different classes, their scopes are different. So you can call it same only, that is okay for me. Now, as I am creating two different threads, I am planning to use the constructor over here, which is using the name, string name. Okay, and if you remember, the runnable target, we have used this kind of object while creating the synchronization example. We have used this kind of object for passing the this object name of the runnable class, meaning our producer class in this instance. So if I want to tell that this is the current object. Meaning, if I want to mention that this thread is the thread created for this class's object only, then I can again use this keyword over here. Otherwise, if I want to create the threads from this point onward itself, no, then I can do it like this, that thread, suppose T1 equals to new thread, and you can pass here OB1. Both the things are same. Okay. Whether you are creating the thread outside this class, from here itself, whenever you're creating thread, it is also okay. And you call it events dot start, both are okay. This you have seen in the last session, passing the object of the implementable granular class over here. Okay. You can do this thing also, or you can even start the thread inside the same class also. But how to start the thread inside the same class? Mentioning that I am calling it should be the object of this class, meaning which class our current calling object, that is producer class, and I can use the name as this is from the producer thread. I'm using the name as producer thread. Okay. Same I can do here also. I can create the thread over here. It is okay for me. And I just want to name this thread as consumer thread because we can get to know who is currently accessing the value, who is getting it and who is putting the value. So I'm naming it as consumer thread. I'm naming this as producer thread. Okay, in the constructor itself, I'm doing this thing. From the moment you see, I don't need to call these two functions now. Why I don't need to call? The moment you create the object, at the same time itself, it is instantiating this R, as well as it is also creating this thread, and it is also starting the thread at the same point itself. It is also starting the thread, right? Because I'm calling start. No, the control will directly go over here to run. I don't need to call start here explicitly again now. Automatically start is going to start the current classes thread, because I've mentioned here this I'm referring to the current classes object. It is going to start the current classes start function, and then in turn it is going to call the run function, which is going to simply put the value of this I infinitely. And same for consumer also. I'm starting this thread, meaning it will directly call the current classes thread you have to start. Because I've put here this, no, it is going to start the current classes thread, that is nothing but the consumer's thread. So it is calling the run method directly. So far, anybody is having any questions so far? Refer the code. I am okay with that. Refer the code once, twice, thrice. I am okay with that. Let me know if you have any questions. I'm waiting for you. It is going to be a big fat example, so definitely I'm going to give you time to refer it. That is okay for me. But let me know if you have any queries. Okay, still I'm waiting for a few seconds. Just try to digest these things, what I'm doing here. We are creating a separate class resource, and I want the resource to be same for both the classes, which are threads. So I'm creating and passing the resource object here while creating the object, because I want both the threads to access the same memory location with the same variable number. So I'm passing here R, and which R is going to get passed over here, which are that you are creating over here. No, the same R is passing over here in producer and consumer both. And once you are creating the constructor, it is calling this body, initializing this object R with this whatever value you have passed over here, and it is also starting and calling the run method. Anybody is having any questions so far? I'm giving you one or 2 minutes with this. I'm okay with that. Just refer the solution. Then we are going to see how synchronization is working here, and then we are going to see how wait and notify will work here. Yes, anybody having any questions so far? Yes, anybody having any questions so far? What about you, Manyar? Darshan? Okay. Jignesh Prasad, what about you? Okay. Okay, fine. Fine, no problem. Okay. Then I want to show you, I haven't used any synchronization yet. We haven't used any synchronization yet. If I run this program right now, without synchronization, what is happening? Let us see that. Without synchronization, okay, I haven't kept the sleep method, so it is running like that only. See, without synchronization, what is happening? Or, okay, yes, from now itself we can see. If, see, I haven't kept any sleep method yet, so it is running without, halting for a second. If we just keep here the sleep method, no, then it is going to, get and put with, with that pause. So we can implement here sleep, the sleep function that you all know. I can make this thread sleep for, half a second. And as it is throwing exception, I can simply, or maybe after you are putting the value, you want to sleep. After you are putting the value, you want to sleep, or before, totally it is your choice. I am just using the sleep function to, make that pause in the execution. Otherwise, it is going to run infinitely without, stopping. Okay. I'm creating the catch block here. I'm not printing any messages yet because I don't want to print any messages. Okay. And at the same time, as soon as you are, getting, you want to sleep. Any which way you want to sleep for, you want to give a pause for half a second, something like that. Then it is, see what is currently happening now. See this discrepancies over here. It is putting 0, it is getting 0, okay. It is putting 1, getting 1, okay. Putting 2, getting 2, okay. Putting 3, getting 3, fine. Put 4, get 5, okay. But before even putting 5, it is getting 5. See. And after it put 5, no, again it is getting 5. See. See the discrepancies over here. It is putting 6, but did it get 6 anytime? No, it didn't get 6. Because there is no communication in between both the threads, it is this scenario is happening. Before it is putting 3, it is accepting 3. Before it is putting 5, it is getting 5. If in the pool 5 doesn't exist, then you cannot get 5. No. Because the methods are not having any communication in between. There is no communication between consumer thread and the producer thread. So it is constantly keep on putting it, and even the consumer is constantly getting the value before it is putting the value of I. Before the put function is executed, it is constantly getting the value of I. So these discrepancies will occur when there is no communication between two threads. And even after you synchronize this method, see, I haven't synchronized the get and put method, okay? Which means that if one thread is holding the put method, then another thread cannot access this method. If I use synchronization over here, if I use synchronization, if I qualify that both the method is synchronized, then also what will happen is you are having different threads. No, see here, it is putting 0, it is getting 0. Then again it is getting 0 because there is no communication between both the threads. Even when you are, see, it is constantly putting 5 and 6 because both the functions put is handled by one whole separate thread producer and get is handled by another thread consumer. So it is going to have lock on put. Once you are reading synchronized, this means that if your producer is holding this lock, consumer cannot put. But any which way, consumer is never putting anything because your logic says consumer is only getting the resource. Consumer is never putting anything. So both the threads have individual access to both these methods, put and get both. Even if you synchronize both the methods, the use of synchronization is if one thread is holding put, Another thread cannot come and access this method. This method is locked by that thread only. But any which way, it is only accessible by one thread producer. Consumer is not even touching this thread, this function. Then even if you put synchronized keyword over here, no, it is going to act abruptly. Why it is working like that? Because you have get 0, no. Now it is the chance for put to put 1. Don't get again. You already got 0 once, no. Now notify put. Ask put to put something, then you can get something, no. See, the sequence of execution is totally changing over here. Because we don't have control over both the threads. There is no communication between both the threads over here. Are you identifying the problem first? It is putting 0, it is putting 6, getting 6. Now the turn should be of put, not get. Why get is coming again over here? Because get is having only one task to do, getting the value. It is not notifying put. Get function, this consumer is not notifying put to now put 7. It is constantly getting it from the pool, whatever it is getting. And once put is putting 8, put should wait for, see the words that I'm using here. The same words are going to write in the program itself. Once you are setting the value of number, you have to wait for get to retrieve this value. Get is not retrieving this value. Then you cannot put another value. No, you have to wait for get. Once get this consumer thread gets the value of 8, it notifies put. Okay, now you are good to go. Now you can put one more variable over here. It is okay for me. Are you getting the synchronization, the task that should happen over here? The sequence that should occur over here is that as soon as your put is putting a value, your producer is producing one value, your producer should wait for consumer to consume. If your producer is not waiting, then consumer will always retrieve the incorrect value. So once you are producing one value, your producer should wait. It should wait for consumer. And once consumer consumes the value, it should tell the producer that, okay, I have consumed, now it is your task to produce new value. So this synchronization should occur over here. This communication should occur in the process. Inter-thread communication should occur. Even if the methods are synchronized, then also there is a need of inter-thread communication. And that communication can be achieved by these 3 methods: wait, notify, and notify all. Are you getting the problem first? Then you can get the solution. Are you getting from this output? Are you getting the problem first? Yes. Now let us see the solution. Regarding the solution, what should happen is, as soon as you are putting a value, you have to wait for consumer to consume that value. That is the logic over here that we are going to work here. The logic is, as soon as you are putting the value, you have to wait. Where are you putting the value? In this put function. So just like, a flag or something, I am creating a Boolean variable, just a flag itself. Okay, I am creating a Boolean variable. Say, for example, are you, let us name it as, flag. Okay, let us name it as value set only. It is understandable very easily. I am creating a variable value set and I am naming it as false. Once you are setting the value, you make it true. Okay, when are you setting the value here? No, you are setting the value here in this function, right? As soon as you are setting the value, no, you make this value set flag as true, meaning I have set the value. Now get, you have to go and get this value. Okay, get is currently waiting. I am coming to that wait state later on, but just understand this. Currently your flag is set to false, meaning you haven't set any value yet. Once your number is set the value, meaning you are initializing your number with the updated value, you are making this value set as true. Now the flag is true. Now get a consumer, you are good to go. Consume the value. So as soon as it consumes the value, it sets again the flag as false. Why it is setting the value as false? Because the consumer got the value, right? Now it is making it false because set it again, make it true, I am consuming it. So I am making it false. Again, the producer is setting the value, it is making the flag true. Only when the flag is true, the get is going to consume the value. Once the flag is true and this get is consuming the value, it is resetting the flag to false. You are setting the value, set the value and make the flag as true so that the get can read the value. If the flag is true, then only get is going to retrieve the value and again set it false because now I have extracted the value. No, the shelf is clear now. Produce some new value and set the flag as true. Are you getting what we are doing here? What I'm explaining you? Are you getting here? What is why I'm making here true? Why I've kept a flag? The flag is simple variable over here, which is used for enabling and disabling get input function. As soon as I'm setting the value, no, I'm setting the value of this flag as true because I want to inform the get function or the consumer that okay, hello, now get this value. Okay, it is set by me. Go and get the value. Once the get is retrieving the value, it is resetting the flag to false because the shelf is empty now. The producer has to produce more values. Are you getting so far? Is it clear in your mind? Yes, are you getting this? What I'm telling you here? Okay, so what I'm doing is once your value is true, so when does consumer has to, when does the producer has to produce the value? When the flag is false. Whenever your flag is true, meaning till the time your flag was true, till the time your flag is true, the producer has to wait for what? For consumer to consume the value. Understand this? If your value set is true, it means you have set the value, but the consumer has not get the value. The consumer is not retrieving the value. So until and unless, that is why it is going to be a loop over here. Until and unless your flag is true, wait for the consumer to consume here. You are waiting. As soon as the consumer is getting the value, it is setting it to false. Again, when should the consumer wait? The consumer should wait whenever your value set is false. Whenever your value set is false, it means your consumer has to wait for the producer to produce or put the values. Because if it is false, no, then producer is still producing it. See, if it is false, it is putting the value, producing it, and then setting it true. If you are setting it true, wait for the consumer to consume it. And once the consumer is consuming it, no, you will be setting the value to false. Till it is false, you have to wait for the producer to produce it. And this wait function is different than sleep function. Wait is different than sleep in the sense your sleep is going to make the thread sleep for this much amount of time. Then again the thread is alive. Again the thread is going into the running state without nothing doing. We are not doing anything. As soon as the time limit is exceeded, no, it is automatically going to the vacant state or the running state. It is sleeping for this much seconds only. But this wait is like infinitely waiting. Till when you will wait? When you will wait? As soon as you are setting the value of this flag to true, no, you notify the thread. Which thread you are notifying? I am notifying the get thread. I have set the value to true, meaning I have produced something. Go and fetch the value. So get is fetching the value. Once get is fetching the value, it is notifying the put thread, meaning the producer that thread that I have fetched the value. Now go and produce something. So whenever you are using wait, it is always, it is ideal situation is you always have to use notify to wake up the another thread. You are using notify here to wake up this thread. And this thread is using notify over here to wake up your producer thread. Is so far clear? Is everybody getting what I'm doing here? And this wait function is actually called using try and catch. Okay, because if somebody is going to notify you before your operation is finished, then it is going to, catch the exception. That is okay. We can simply catch the exception like this. That is okay. Right. But so far, is it clear to everybody what we are doing here? Yes or no? Okay. Okay, fine. Then, if we run the program now, we can see that, see, it is working in synchronization now. See, for any number of values you take, unless and until you are not putting, get is not notified. Once you put, get is notified, get is taking the value, notifying the put again to produce value. They both will work in synchronization now. See the output. They both are, unless and until your put is not doing the put, your put is not producing something, get will never get the value. Once your put is setting up the value, once your put is producing a value, it is notifying your get that okay, I have produced, huh? Now go and fetch the value. So get is fetching the value, and till that time, while get is fetching the value, your put function is in the sleeping mode. Not in the sleeping actually, but in the waiting mode. Okay. Once your getter is fetching the value, it is notifying your thread to produce more values. So they both will work in synchronization, and your get will always be executed after your put is done. Before put, the get will not work. And after get has worked, get is notifying put to produce or generate more and more values. Yes, anybody is having any questions so far in synchronization? What is notify? What is wait? Why are we using this flag to set the value? Whether it is generated or not, or whether the shelf is clear for getting or generating more values or not. Anybody having any questions so far? Okay. Okay. Then your threading is ending over here. Your multi-threading unit is ending over here. What we have seen so far is what is multi-threading, multitasking, multiprocessing, how to create threads using two methods, different methods of thread class, getter, setter, sleep, wait, notify. Then, this priority that we have seen to prioritize the execution of the thread, right? Then get name, set name, get state, all these functions that we have seen. We have seen synchronization, synchronized blocks, synchronized methods, and we have seen today the communication of threads, intercommunication of thread when it is synchronizing. Using producer and consumer problem, we have solved the problem currently. Anybody is having any question in these topics that you have seen? Anybody having any question in any of the topic of multi-threading? You can ask your questions. Okay. Okay, fine. Then you are done with this unit. We are going to start this another unit in the next session itself, not today. You are done for today. Just look at the program. I'm giving you a few minutes to look at the program. It is going to be an examination question also. It could be an interview question also. It could be a problem given to you in coding contest also. Just look at the problem and let me know if you have any questions. I'm showing you the solution again. If you're having any questions, just let me know. Anybody having any questions in the code? Okay, I'll take the attendance and then you all can leave. Ayush, Rohan, Vipin,
Present, ma'am.
Manav, Anuj,
Yes, ma'am.
Siddhi, Vidhi,
Present, ma'am.
Yashraj, Josh, Mansi,
Yes,
Nikita, Manthan, Smith Kumar,
Yes, ma'am.
Devansh,
Present, ma'am.
Ala, Yashang,
Yes, ma'am.
Ma'am, Divijit is present. He has
yes,
written chat box.
yes, Dipen,
Yes, ma'am.
Tushar, Yash, Manya,
Present.
yes,
Present, ma'am.
yes, Parmar,
Present, ma'am.
Beraj, Rishabh, Ivanchi,
present, ma'am.
Janvi,
Present, ma'am.
Anchali, Harshvardhan,
प्रेजेंट मैम
yes, Vijayaraj,
मैम ऋषभ
Present,
भी
ma'am.
प्रेजेंट अपने चैट बॉक्स में लिखा है
Rishabh is there, okay, yes, Adania,
Present, ma'am.
Bharti, Avinash,
Present, ma'am.
Pranjul, Limbani,
Present, ma'am.
Arjan, Maharana, Anmeraj,
Yes, ma'am.
yes, Dignesh Prasad,
Present, ma'am.
Anjwani, Sushil Prasad,
Present, ma'am.
Dhruvi,
Yes, ma'am.
Netik, Armik,
Present, ma'am.
Mohammed, Kunal,
Present, ma'am.
Nidhi,
Yes, ma'am.
Arpit,
Present, ma'am.
Meghna, Yash,
Present.
yes, Divya, Saif Ali,
I'm 39.
Meghna, you are there, yes. Saif Ali,
Yes, ma'am.
yes. Samir Alan,
Yes, ma'am.
Isha,
Present, ma'am.
Vibhusha,
Yes, ma'am.
Om Parik, Aditya,
Present, ma'am.
Viplani, Aditya Jain, Jay Dakan, Priyank,
Present, ma'am.
Tushar,
प्रेजेंट मैम
Nikita,
Present, ma'am.
Girish,
Present, ma'am.
Pratik,
Yes, ma'am.
enrollment number 62, Shri is there, 61, 59, 60, 63, Hima,
Present, madam.
65,
Present, ma'am.
73, Mohammed,
Yes, ma'am.
Darshan Raj,
Yes, ma'am.
Dedeep, Smriti is there, Vaishali, Vasu,
Present, ma'am.
yes, Kunal,
Present, ma'am.
and Hollywood is there. Then you all can leave the session. If you have questions, you can stay. Otherwise, you can leave the session.